Hello everyone. So no, no. Right, it's good. Let's check it out. Oh no. Alright. Mm-hmm. The smallest pair of each different frequencies. Alright, good. Alright, so we got the integer array nums, consider which consider pairs of distinct values x and I, such that x smaller I. Uh-huh. Right. So let me screenshot it. Oh yeah. Am I actually now? Alright, so good. Hmm. So, hmm, among all valid pairs, we minimize x, and if several pairs have the same x, we minimize I. So we return x I or minus 1 if no such pair exists. So let do this. Pairs in nums. Alright, so with a set of distinct values. So now it's as set bigger 0. So it's a bit of frequency map where f from v is the count of v in nums. So we need x I as on as a subject to x lower I, and f from x f I. So, and lexicographically we minimal by value. It's x I, well, arg min a b. So a b is a lower than b, f from a, f from b. Right, so nice. And under the order it's a b lower than c d, and a lower than c, or a equals c and b lower than d. So we sort all distinct values. It's v1 lower than v2, and lower to the vm. So for fix as small as possible, it's x equals vi. So the best I is the smallest vj, and j is a bigger I, such that vi Very good. Now when important compression, so is there... Oh, oh no, my mouse is dropped. Alright, good. So after counting the frequencies, we only need sort distinct values and scan J-can pairs and return first pair with different frequencies. So this is most optimal and most simpler that checking all pairs. So I use in this structure the another map. It's maybe int for frequency table and vector int a's for the sorted distinct values. So let's sort the distinct values be like this. So we need to vector in. No, wait a minute. We use another map int c for int x nums cx plus plus. So we seek the smallest index I such that such that maybe a I not equal c a from I plus 1. So then the answer is a from I and a I plus 1 if no such I exists, and for all I in 0 and m minus 2, so which implies by transitivity it means we vector use vector int a, no, I reserve c dot size. Alright, good. And so for up to a push back be first. Alright, good. Now we need to sort it. Now we need to make this size I plus wait a minute. So first then two distinct numbers, yeah. So the all distinct values have the same frequency. Alright. If CAI well, CAI plus 1. And now we need to return AI A from I plus 1. And then return minus 1. Alright, good. Let's check it out. Alright, so output 2 3, expected 1 3. Alright, so so then use the alternative. It's counts of frequencies. So yeah, for each value u in nums of f from u, and then equal f from u plus 1. So now we need to distinct values. It's mean equal search S. So Z is 0, lower A1, lower da 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 A M means 1. Alright, so we can put array n from I, it's base in I means 1, means 1. Alright, so we need to use transition from right to left. So for position I, let I plus 1 be next value. It's a piecewise recurrence. So why if adjacent frequencies differs and the smaller wild I is immediately a from I plus 1. So if they are equal, then every index in that equal frequency run must skip together to the same next different frequency position. So this is essentially pulse compression over blocks. So we do right, very sharp in size. Push back, start begin. We can start here and make the int m a size. If m lower than 2, we return, just copy that, return minus 1, and then vector int n m minus 1. So for int I m is 2, I bigger or equal 0, and I minus minus, so then n from I equals C A I, oh no, C A I plus 1, I plus 1, n I plus 1. Alright, good. So here is AI n. Okay, let's just write it. We need to favor then two distinct values, and all distinct values have equal frequency. So for int I equals 0, I m plus plus if n from I minus 1, and here I can use a from I. Alright, good. Let's check it out. Alright, so it's the complexity analysis. I can say it's time complexity. I mean time complexity. It's O n plus m log m. So there's n norms, and m it's a number of distinct values. So it's just O from m. What can you explain? How do we eat fast? I mean, so imagine our numbers are toys, alright? It's you count how many copies of each toy you have. Example, one, one, two, two, three, and four. Right. So um, one, we got two toys. Two, two toys. Three, one toy. Four, one toy. Right, we want two different story labels. It's the first one is as small as possible. Second one also as small as possible, but their box size frequencies, yeah, frequencies must be different. So we line labels up. It's one, two, three, four. Their counts is two, two, one, one. So now try the smallest toy one. It's a compare with two. It's the same count, not good. Compare with three, different count. It's a good. So answer is one, one, three. So how do we eat fast? We walk from the right and remember for we remember one for this number where's the next place to the right where the count changes. So then we scan from the left and take a possible answer. So it's like each toy says if my next neighbor, yeah, has same number of copies. So and then we ask him where the first difference is one is, so that makes it fast. Right, so yeah, thank you for watching. It's my first video. Goodbye.